Okay, we're picking up with example 13.4 where we left off. We had found the shear value at this point. The shear we found in the first video was equal to, let's see, what was it? 5.33, specifically negative, following our sign convention, negative 5.33 kips is the amount of shear at this location. Now we would like to know what is the moment. So again, we take the same approach of chopping the beam in half and just looking at the right half. We could equally do this with the left half. I just think that the right half is simpler. And so we've got this 15.33 kip reaction force at B, and we have 2 kips per foot distributed load spread out over a span of 5 feet. So that makes for a total load due to the distributed load of 10 kips applied at the midspan of this half of the beam, so at 2.5 feet from this edge of the beam. So this 10 kip load is going to cause a moment in the clockwise or negative direction. The reaction force is going to cause a counterclockwise moment. And I can tell just by looking, because this is a lower force number and a lesser moment arm, that the two of these moments combined are going to result in a net moment in the positive negative direction. The 15.33 load is larger than 10, and its moment arm distance of 5 is larger than 2.5. So it's going to result in a net counterclockwise moment, which means that the internal moment is going to have to be going the other way to cancel that out. So let's sum up what those moments are. So we can call this moment, I don't know, I suppose we could call this point C. We've got A over here at the left support, B over here at the right support. We'll call this one C. So I'll label it with a subscript C. We want to know what this moment C is. It has to cancel out all of these others. So the sum of the moments about C is going to be equal to 0. And so those moments include 10 kips times a moment arm distance of 2.5 feet, and also the 15.33 kips times 5 feet. Again, this is negative, this is positive. Oops, let's undo that, sorry. And so, and then also we're going to have the negative MC, whatever that is, equal to 0. So MC therefore equals, let's see, I'm going to take the MC over to the other side of the equation, so it will go from a negative being positive, and I'm left with signs over here. On this side will stay the same. I'm just going to put the bigger one in front, 15.33 times 5 minus 10 times 2.5, and that equals 51.7 kip feet. Should be an FT, kip feet. So so again, the moment, the internal moment here on this side is going up in this direction. The net moment on the other side is going up in that direction. So they are going to cause this beam to bend like this. We got the bend moment here and the moment here. So that's a positive smiley face. That is a positive moment. So it's positive 51.7 kip feet. So that's equal to positive 51.7 kip feet. And the magnitude of the moment and the shear is going to vary across the length of the beam. If I were to say, choose a point right here. I would have to go through the same process of creating a free body diagram of the either the right or left side, summing the forces, summing the moments, finding out what the internal shear and moment is here. If I asked you to do it over here, we'd have to do it again. If I asked for you to do it over here, you'd have to do it again. And so that would become very time consuming. And as a design engineer, you want to be able to quickly determine what is the maximum moment, what is the worst case scenario, what is the maximum shear, and where are those occurring, so that we can be sure to design the beam appropriately. So the key here is the solution is to make a diagram, that will show us all along the length of this beam, from one side all the way over to the other, how this moment and shear forces vary from support to support. And those diagrams are called shear and moment diagrams. They're two separate diagrams that will show us graphically what the shear is all along the beam and what the moment is all along the beam. So there's a process to follow to make a shear and moment diagram, and I will introduce you to that process in the next video.